Excuse me. All right, angle, side, angle, 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 side. Let's see, which ones are not proofs? Let's see, any of them? Number 6 is a proof, 8 is a proof, 10 is a proof, 12 is a proof, 14 is not, 14, what's that? 14, x equals 3. And 16 is over here. Oh, there we go. 16 was also a proof. And everything's a proof. Which ones do we need to work on? 12. 1, 2. Buckle my shoe. All right. So over here. Oh. Gavin Elder. What does this say? You're on. Well, how am I supposed to know you're going to join on Discord? Did I get a message about that? Okay. Maybe, maybe not. Don't know. That's fine. Okay. You said 12? Okay. Studio. Excuse me. I don't guess there's any point actually in opening that because I'm going to have to be over here. All right, Gavin, I don't know if you're here or not. I can't tell.
I'm here.
Okay, good. Well, there you go. Oh, you look. And now I can see that you're there. It's great. Okay, so we're going to do number 12. All right, we got a triangle that looks more or less like this, that has this, that kind of looks like a median, which I don't know what that means yet, but you will next chapter. J, K, L, and M. And we're supposed to prove that segment JM is congruent to segment LM, and we are given that segment KM bisects angle JML and angle J is congruent to angle L. Great. So, this is 12, right? Yes, this is 12. Did you do the wrong problem? Did you do what I told you to do when you asked about it and do the right lesson and the same problems? Okay. 4 or 5, right? Is that what we're doing? This is number 12. 1, 2, proof, write a flow proof, but we're not doing that. Okay. This is it. All right. So, What does KM bisecting angle JML tell us? Let's start with that. Something's congruent. No, it don't make no sense. It bisects the angle. What does bisect mean? Bisect means cut in half, right? Yeah, both of these angles, right? This one and this one. So what do we call this angle? This one right here. There's two angles at M. We can't just use M. MJ would be a segment. We need 3 points for an angle. And M would be in the middle, right? MJK would be this one. You got to have the one where it is where the angle is in the middle. So it would be JMK, right? So angle JMK is congruent to angle LMK, right? Angle LMK. What is the justification for that? What? Definition of bisector, that's right. Definition of angle bisector. Great. So we got a couple angles. If we get a side, we're golden. Can we get a side? Yeah, which one? We can get a side. We can definitely get a side. LM, no, LM isn't even in both the two triangles are these two triangles. LM isn't even in both triangles. MK is in both triangles. MK is congruent to MK, right? What's that called when you say something is congruent to itself? You're close. You're you have it like right there. Not reflective, but reflexive. You were like right there. You were right there. Reflexive property. Great. Now what can we say? Now what? Well, so the triangles are proved, right? We got to do one more step to get to this, but the two triangles are congruent, right? So triangle JMK is congruent to triangle LMK because of why? Not angle side angle, that's different, right? Because I would have the side in between them, but it is angle side though. Great. Now what can we say? No, it's since this, right? Not since this. It's since something over here, this. Since the triangles are congruent, what's true about their corresponding parts? They're also congruent. So JM is congruent to LM because CPCTC, corresponding parts of congruent triangles are congruent. There's no R. Oh. There you go. There's an R. What other questions from this lesson? 20. Okay. Don't I have, speaking of doing things, don't I have a quiz to get back to y'all? Let me see. Yeah, is this y'all? This, you, that's Eden, that's Gavin, that's Mia, and that's Joe. All right, back to number 20. We have a bow tie looking shape. Looks more or less like this. And Q, R, S, U, W, V, and T. We've got these labeled like this. We're supposed to prove that segment QT is congruent to segment WU. What? 281. So since it says we're proving a couple things congruent, we're going to end almost certainly with CPCTC, right? So we should keep that in mind, right? We're going to get a couple triangles congruent, then we're going to say their corresponding parts are congruent. That's almost certainly where this is going to end. It's worth kind of keeping that pattern in mind. And we are also given, let's see, at least that those segments are all congruent, right? And that's it. We're given that QR is congruent to segment SR is congruent to segment WR is congruent to segment VR. Virtual reality. QT. Let's see, where's QT? QT. So we're looking for this one is congruent to this one. Right? That's where we're headed. So we want this triangle and this triangle is really, if we can get those two triangles are congruent, then we are sitting pretty. Okay, so what could we do? There are, absolutely, and I do think that's a good idea. Absolutely. We may have to, so there's like triangles intersecting triangles and intersecting triangles, right? So there's all kinds of stuff happening. I feel like the book goes in a wild direction because they say this one is congruent to this one because vertical angles, which is true, but these are also vertical angles, right? So that seems like a reasonable way to go. All right, vertical angles. Angle QRT is congruent to angle WRU because of vertical angles. That's true. Now we've got an angle and we've got a side. That's helpful potentially. What else could we do? Oh, we may have to do the big ones. Oh, yeah. I see why they did it that way. We may have to do that. Because can we say anything else about the little triangles yet? No, unfortunately not. If we had like, these were parallel or something, then we could do some transversal shenanigans and start to do some stuff with like these angles being altered, but we don't know they're parallel. They probably are, but we don't know that. Mike could write a proof for that. So for the same justification, we'll go ahead and tack on because it's the same thing. The big one, because this is going to get us something. This can get us something that's some triangles that are congruent, which might give us a hand. Oh yeah. I see where we're headed. Now let's see if we can figure it out together. So the big angles are also congruent. So angle QRV is congruent to angle WRS. Same justification. Now, I've said this before, and it's worth saying again, that sometimes you're like, I don't know how to get there, but I know this is true, so I'm just going to start writing stuff. I never, when I do proofs, I never count off because you have extra stuff. Only if you don't have the what you need. So sometimes it's like, I don't know why this might help me, but I know it's true, so I'm going to shove it in there and see what happens. But now we have something with some triangles. We have one of our proofs. Remember our different proofs for triangle congruence are side, 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 angle, side, angle, angle, side, and angle, side, angle. Those are our options. We have one of those for some of the triangles. What do we have? We do for the big triangles, right? Side, angle, side. Absolutely. So let's go ahead and write that. So, triangle QRV is congruent to triangle WRS because side, angle, side. So we have these big triangles, which means all of their corresponding parts are congruent, which is useful. All right, now what could we say with that? We are going to need the first orange thing that we wrote. That's good. It wasn't useless. Remember, we're headed for these. We want to know something about these little. We know these big triangles, and if we can get these little ones congruent, then we can be pretty nearly done, right? We know the big ones. We know this. We know this one is congruent. This big one is congruent to this big one, right? And we know that if two triangles are congruent, then their corresponding parts are congruent. So what can we say that goes with the triangles we're headed towards? Which part? Q and angle Q. V, what? QRV would be this angle right here. And it's congruent to WRS. We already said that, right? So let's take a step back. So CPCTC says that corresponding parts of congruent triangles are congruent, which means that this is congruent to this is congruent to this, these are congruent to these sides, this is congruent to this is congruent to this is congruent to this, right? So all of the corresponding parts, when we're looking for something with these blue triangles, so what angle or sides do we know are congruent because of CPCTC that's in the blue triangles? What? R has got all kinds of crap going on it. What is something that is unique in each one of these? These are the blue triangles. This one and this one. There's an angle in there that we can now say is congruent. Q goes with W, R goes with R, V goes with S. Which one of those are in the blue? What set of those is in the blue triangles? True. R, what else? What else? And Q with which one? With W. Q is congruent to W because these big triangles are congruent. Q is congruent to W because corresponding parts of congruent triangles are congruent. CPCTC. Angle Q is congruent to angle W because of corresponding parts of congruent triangles are congruent. CPCTC. So now we've got this congruent to this. So we've got an angle, and a side between them, right? Does that work? Is that a proof for congruent triangles? See or no? Angle, side, angle. Angle, we have an angle, and a side, and an angle. Is that a proof of congruence? Yeah. The only one that's not is ASS, right? Any other combination works. I know, and hopefully that'll help you remember that it doesn't work, right? And that's not why it doesn't work, but it is a convenient way to remember it, right? So triangle, Q, R, T is congruent to triangle W, R, U because of angle, side, and angle. Now, like we started at the beginning of this proof, because those two triangles are congruent, what's true about all their corresponding parts? They're also congruent. So QT, can't even write things, is congruent to segment WU because corresponding parts of congruent triangles are congruent. CPCTC. We did it. Easy peasy. What other questions from this lesson do we have? Why? You did this whole asking me about it, which was good. Oops. We already did 4-4. So you redid some stuff? Well, maybe that's extra practice. I don't know. Gavin, did you have any questions?
No, sir.
That's crazy. Okay, well, in that case, boys and lady, let's take a quiz. Which one do I want? Do I want that one or that one? What time is it? Yeah, let's do both. More points. It's great. You could screw up a little bit more and fail less. Page. This is quiz 4-5. And it's going to be from page 279. And it's numbers 7 and 9. Ready, set, go.